Hey there. If you're in college right now, your day is probably just packed with noise, right? Deadlines, endless to-do lists, and a million things constantly demanding your attention. So for the next few minutes, let's just take a breath. Let's step away from the high-pressure exams and the stressful lectures. Today, we're going to explore the unseen materials that quietly support our daily routines. Specifically, we're looking at the chemistry of a material that makes life just a little bit smoother. The quiet chemistry of Teflon. Have you ever wondered why, when you're rushing to make breakfast before an 8 a.m. class, the eggs just slide right off your favorite pan? Or how your laptop charger, which you literally probably leave plugged in all day long, safely handles all that electricity without breaking a sweat? These are the smooth, frictionless moments in our often overwhelming lives. They're moments of perfect functionality that we totally take for granted. But behind these seamless interactions, there's a fascinating, invisible world working exactly as it was designed to. Which brings us to the magic of everyday life and finding calm in the things that just work. At its core, applied chemistry is really just about creating materials that make our lives easier. Imagine an invisible shield. When you use that perfectly non-stick pan in your dorm kitchen or run your fingers along the smooth texture of a computer cable, you're actually interacting with a highly engineered barrier. This shield repels water, it resists heat, and it blocks electrical currents so you can just go about your day safely. Let's uncover exactly what the shield is made of. So what exactly is Teflon? Let's look at the simple recipe behind the magic. You likely know this shield by its common brand name, Teflon, but rather than looking at it as some intimidating chemical compound, it's really helpful to just look at it as a microscopic recipe. Its scientific name is polytetrafluoroethylene, often abbreviated as PTFE, or sometimes known in engineering as fluon. I know, polytetrafluoroethylene sounds like a massive mouthful, but let's demystify it. Poly just means many, so this is simply a long chain of smaller molecules basically holding hands under pressure to form a continuous, incredibly strong synthetic polymer. If you look at the molecule at the bottom half of this diagram, you'll see tetrafluoroethylene. It's just composed of carbon and fluorine atoms. Through a process called addition polymerization, which honestly just means adding these units together one by one, and with a little help from a catalyst called benzoyl peroxide plus some pressure, these individual molecules link up. They open up their chemical bonds and join together to form a strong, continuous chain that won't easily break. And that brings us to the power of fluorine, which forms a really tight-knit molecular community. The secret to why this chain is so incredibly strong lies in those fluorine atoms. Fluorine is highly electronegative. Now, what that means is it holds onto its electrons very tightly, creating a tight-knit molecular community that really doesn't want to interact with outsiders. And because they hold on to each other so firmly, PTFE has a super high melting point of 350 degrees Celsius. It's dense, coming in at about 2.1 to 2.3 grams per cubic centimeter. And because it totally refuses to share electrons, it becomes a remarkably powerful electrical insulator. It basically creates a barrier against the chaos of heat and electricity. Because of this tight-knit structure, Teflon possesses high toughness and high chemical resistance towards almost all chemicals. Honestly, it's nearly invincible. But like any good superhero, it has a very specific kryptonite. On one hand, it effortlessly resists the vast majority of corrosive substances. But on the other, it's vulnerable to two very specific extremes: hot alkaline metals and hot fluorine. But unless it encounters those super rare extremes, it remains a totally steadfast protector. Let's look at Teflon in the real world, anchoring this chemistry to your daily routine. Now that we understand its sturdy nature, let's see how this polymer actually shows up in your day. Because it naturally repels other materials and withstands heat, it's famously used for non-stick surface coatings on your cooking utensils. And because it's such a brilliant insulator, it coats the cables that keep your laptop and your phone safely powered up. Even in the heavy engineering world, its toughness means it's used to make seals and gaskets that withstand crazy high temperatures in heavy machinery. It's quite literally everywhere. Interestingly, to make a great material even better, engineers sometimes mix it with something incredibly simple. They found that by adding just a bit of china clay, which is a natural, earthy material, they actually improve the electrical insulation properties of Teflon. It's kind of a cool reminder that even advanced synthetic polymers can be enhanced by the simplest natural elements. Which leads us to a smoother daily life and finding peace in the unseen. We've zoomed way in on a microscopic chain of carbon and fluorine, and then zoomed back out to the cables sitting right there on your desk. Chemistry is constantly working in the background, quietly providing a buffer between you and the harsh elements. So the next time you plug in your phone or make some eggs, maybe take a second to ask yourself, what other invisible forces and materials are quietly working right now to make your day just a little bit smoother? You really don't have to understand all the complex equations to appreciate them. Thanks for hanging out and taking a moment to discover the quiet chemistry all around us.